Good morning, 8th graders. Mr. Hale here. I hope you and your families are safe and well, that you're staying home as much as you can, washing your hands, and that you had a relaxing weekend. Today's the first day that we are moving our lessons online using OneNote. Thank you to Elias, who caught the fact that my first YouTube video was corrupted and you weren't able to hear me. So here is my second take on this particular video. Since you guys just turned in your paper packets yesterday, and I'm not going to be able to grade all of them for a few days now, and since we are starting this new online lesson thing, and inevitably we are going to run into technical issues, like the one we just ran into with my first video, I'm not going to be introducing new material this week. My plan, while we get everything sorted out, make sure everybody has the access they need, is to review the things that we've already been talking about. So today, I'm going to go over this worksheet that was in your packet on prisms. And specifically today, I'm just going to talk about the volume of prisms. Tomorrow, we'll talk about the surface area of prisms as a review. Then on Wednesday, I'll do the volume of cylinders, and Thursday, I'll do the surface area of cylinders, and so on, all as review, until I can make sure, between your paper packets and the online work, that you guys are understanding this to the best that you can. And then we'll move on to new stuff depending on how much time is actually left in the school year by then. So, for today, we're going to go over these 6 problems from your previous worksheet, specifically the volume of these 6 prisms. And then I'm going to ask you on OneNote to complete a very similar worksheet. It looks almost identical, but I've changed some of the numbers. And all you need to do today, Monday, April 6th, are the 6 volume problems. Tomorrow, Tuesday, April 7th, using the same worksheet on OneNote, I'll have you do the 6 surface area problems. So let's go ahead and review this worksheet from our previous packet, specifically on the volume of prisms. Okay. So, we have a rectangular prism here in number 1, a box. And the formula that you're going to see online and that you're going to see in textbooks will tell you that the volume formula for a rectangular prism is length times width times height. And that's true. But sometimes that can confuse people because they are trying to figure out exactly which one of these 3 measurements is the length and which one is the width and which one is the height. And so I tend to not use that terminology very often. Instead, what I want you to focus on, and this is going to become a lot more important to focus on when you're dealing with triangular prisms, what you're focusing on here is that your 3 measurements that you are using in your volume calculation need to be the measurements of the following 3 things. First, the distance from left to right. Then, the distance straight up and down. No diagonals. We want from the floor to the top. And third, the distance from front to back. On a box, that's pretty easy to understand. You have left to right, in this case is a 3. Your top to bottom, up and down, from the floor to the top is 1.7. And your front to back is 1.1. So our formula, our calculation here, is going to be 3 for left to right, times 1.1 for front to back, times 1.7 for top to bottom. Multiply those 3 things together. I have a calculator at home. If you don't, there should be one on your school laptop, or you can just Google calculator, and there are plenty of free online scientific calculators. The answer to this one, 3 times 1.1 times 1.7, is 5.61. Let's remind ourselves about the units. All these measurements are in centimeters, so we're going to put centimeters, and then since we're multiplying 3 things together, it's to the 3rd power. Volume is always to the 3rd power. What about over here? We have another box, this one tall and narrow. Not going to worry about what's the length, what's the width, what's the height. We're going to look at what's our left to right measurement. That's 10. What's our up and down measurement, straight from the floor to the top? That's 40. What's our front to back measurement? That's 12. So we're going to do 40. Actually, we can put it over here like I did in the first problem. 40 times 10 times 12. And that should give us, if my mental math is correct, 40 times 10 times 12 should give us 4,800. So our volume, number 2, is 4,800. I'm going to run out of room, but that's okay. Notice all of our measurements here are in millimeters, so we're going to go millimeters. If you hear some strange noises in the background, that's my dog wandering around. So we have millimeters, and then since we have volume, 1, 2, 3 things being multiplied together, it's to the third power. I'm going to jump down to number 5. We have another box. In fact, this is the same box that I just stretched and reshaped in Microsoft Word. This time we have measurements in fractions. That doesn't change anything. We're still looking for left to right, that's 3/4. Top to bottom, that's 7/8. And 1/2 is our front to back. Now, on your calculator, if it doesn't have a fraction function, what I like to do is do parentheses, 3 divided by 4, close parentheses, that's the same as 3/4, times parentheses 1 divided by 2, close parentheses, that's the same as 1/2, times parentheses 7 divided by 8, close parentheses, that's the same thing as 7/8. Press enter. It's going to give me a decimal answer of 0.328125. We turn that into a fraction. Our correct volume here is 21/64. And since this is measured in inches, we're going to write IN, and since it's volume, to the third power. We did 3/4 times 1/2 times 7/8, left to right multiplied by up and down multiplied by front to back. We get 21/64 inches cubed. Note that you can't really write the inches sign with the quotation marks thing like we have right here and then put a 3 behind it. That just doesn't work. So if you have inches, you're going to need to write IN and then cubed. Okay, let's talk about these triangular prisms now. So this is the part, these are the problems that seem to confuse the most people when talking about prism volume. We're going to look for the same 3 types of measurement. Left to right, straight up and down, floor to the top, and then front to back. Because there's triangles, there are going to be some diagonal lines involved. We don't need those. We only want front to back, straight up and down, straight front to back. So, let me change my color here to bright green. Our left to right is 21. That's pretty obvious. And our front to back is 35. Good. So let's write those down. We've got to have 21 as our left to right measurement, and 35 is our front to back measurement. So that only leaves, we need the straight up and down from the floor to the peak. And that's going to be this, 18. We don't need to worry about these diagonals on the side of the triangle. We need to go from the floor to the top. And that's a measurement of 18. Multiply those 3 things together, 21 times 35 times 18, you're about 13,230. But wait, remember that a triangle is always half of a rectangle. And if we were just dealing with a triangle and wanting to find the area of a triangle, we would do the left and right multiplied by the up and down, and then we divide that by 2. Same thing applies to a triangular prism. We're going to multiply these 3 measurements together, and then because it's a triangular prism, we have to divide by 2. 13,230 divided by 2 is 6,615. We have millimeters here, so I'm going to put millimeters, and since it's volume, we're going to put cubed. I'm going to make it a little darker green. There we go. All right, moving on to this guy. We have a right triangle now. Over here it was equilateral. Here we have a right triangle. What's our left to right measurement? That's this right here, 4.5. I know that when I printed this out for some of you, that dot might not have been there, and you may have thought it was 45. If you did your calculations that way, I'm going to give you full credit, but it was meant to be 4.5. So 4.5 is our left to right. Our front to back is 8. And our straight up and down from the floor to the peak is this guy, is 5. We don't need to worry about this diagonal side for volume. We only need straight left to right, straight front to back, straight up and down. These slanted diagonal lines aren't part of the calculation. Then all we got to do is multiply them together. 5 times 8 is going to give us 40. Multiply that by 4.5, and you're going to get 180. But wait, this is a triangular prism, so we have to divide that by 2. Our volume is then 90 centimeters, because these are all measured in centimeters. Since it's volume, oops, my mistake, to the 3rd power. Why don't I erase that and make that a little easier to read? It'll be centimeters to the 3rd power. Okay, final example. Very similar to number 4. It's also a right triangular prism. We have a left to right measurement of 25. We have a front to back measurement of 40. And we have an up and down, straight from the floor to the top measurement of 15. 15 times 25 times 40. 25 times 40 is going to give us 1,000. Multiply that by 15, you're going to get 15,000. But then this is a triangular prism, so we got to divide by 2. So our final answer is 7,500. And this is in yards and to the 3rd power because it's volume. Okay, that is our Prism Volume review. Go ahead and jump into the homework folder of your OneNote and complete the 6 Prism Volume problems you find there. Tomorrow we'll come back to this worksheet. We'll talk about prism surface area, and then tomorrow you'll complete the 6 prism surface area problems on the OneNote. I'm doing office hours at 1 o'clock. You should have received a login information via email. Be safe, do your best, wash your hands, stay home, and I hope I get to see you soon. Bye-bye.